In many cases, our radical equations end up looking very similar. We isolate our radical, there's just a number on the other side of the equal sign. When we square, cube, or raise it to some awkward reciprocal power, things work out nicely. That isn't always the case, though. There will be times where there's extra pieces, there's other moving parts, and so as you isolate that radical, in this case by adding 5 to both sides, we end up with a radical that's equal to a binomial expression, x plus 5. Now, when we square, we need to be careful. When you square both sides of this equation, we need to square the binomial, meaning we need to distribute. We need to acknowledge that it's x plus 5 times x plus 5, which means that we're going to end up with, on the left side, x plus 7, but on the right, x squared plus 10x plus 25. When we finish solving this, as we move our way through, we need to combine all the like terms we can. We want to set everything equal to 0. So we'll subtract 7, subtract x, ultimately getting ourselves a quadratic equation that is pretty simply solved if we can remember how to factor. When I take a look at that right side, x squared plus 9x plus 18, I need two numbers that'll multiply to 18, add up to 9. I'm thinking 6 and 3. Now, all said and done, that means that we get solutions of x equals negative 6 or x equals negative 3. Being the good little students that we are, we check our work. When we check, we need to replace x in both places that it appears, replacing it with negative 6. Simplify what's under the radical, evaluate the radical, simplify the left side. Turns out negative 4 equals negative 6. We all know that's not a thing. We'll check our other solution. Subbing in negative 3 for x, we simplify what's under the radical, evaluate the radical, and simplify the left side. Negative 3 equals negative 3, which means x equals negative 3 is our one and only solution to this equation. Now, where did the other one come from? The way that we refer to it is that x equals negative 6, that was an extraneous solution. Now, an extraneous solution is the results of the algebra that we do distorting the original equation a little. Now, if we think about where we've come so far, that original equation started out as the square root of x plus 7 minus 5 equals x. Right here in that step, we squared both sides. Now, in that moment, we actually reinterpreted that equation to not only care about the principal root of that radical. When we squared, we acknowledged that the negative version of that value also exists. Now, if we think about this in terms of graphs, we could graph both sides of that original blue equation. It would look something like this. Now, we can see that on those graphs, with the square root of x plus 7 minus 5 and y equals x graphed, we only get one solution. Taking into account what we just said about that squaring, the negative version of that original equation would also exist. We can see that other solution now, but seeing as how it wasn't part of the original setup, that's why we exclude it. That's our extraneous solution.